Just because we are many, I think what I will do is I will set the register for segregation. Well, I will start teaching here. You can be signing the register, right? Think that's what because you cannot wait until I finish and then say, can you sign because it will take time. So therefore, to avoid that, it's better we sign. I don't know whether from that angle you'll be able to see what I'll be doing here. I don't know whether from this angle you'll be able to see what I'll be doing. If that is the case, I'll edge maybe this row move a little bit, this row move a little bit, because I think all of your eyes should be here, what I'll be doing here. For those ones that what I'll be doing. Then I'll be able to, I think if time, I think we should be able to do is ratios and proportions. I think we should be able to do ratios and proportions today. And yeah, I'm thinking that we'll do ratios and proportions. So you have to get ready and so that you can be writing whatever I'll be saying here. Get ready and be write down based on whatever I'll be doing. Our topic is about ratios. So I'm talking about ratios. Ratios. This is math. Ratios. I hope I sent you this. I sent a certain copy to your group. I don't know whether you have received it. You have received it, right? Yeah. So I'll be explaining based on that. That's all factors that I've sent it in your book. In your book. Let's start with the ratios. As I already said, I'm happy that the class is now full, but they were expecting to have more than now. As we already started with last time, I actually said business mathematics that you are learning, it will guide you when you will be conducting your business wherever you go. I'll be teaching you something relevant to the business. I'm not teaching something outside business, but everything will be in line with the business. That's why I'm starting my topic this afternoon with this one, which is called the ratios. I know you have gone through secondary schools. You know what these ratios are all about. I'm just trying to remind you on what these ratios, what the ratios work. So don't worry, as I've actually said already, I'm not going to go in deep or in detail, but it will be just like fasting, whatever you know. The fact that you are here, you fast these ratios. Hence, I'm just more or less like reminding you what you already learned. When you have a problem, you can contact me through the group or individually. You can see me in the offices that we stay. So we are looking at ratios. If you happen to put your phone on silent and open that document that I say, I think I'll be able, we can be able to follow each other. Now, if you don't have a phone, it's fine. But I'm just saying, if it happens that I've got a phone and you are on that group, then what I'm saying is, you can open that document about that I said, and you can be following me. Because what I wanted is just to show you examples. But some of the words that are there, I will not speak them. We can't write on mathematics, but I have just to tell you exactly what you have to do. So you can put your phone on silent and then open that document in your phone. Are you there? You don't have the document? Huh? Yeah, that one. It has got pages up to 160. 160. Yeah, 160. But you have, yeah, that document, the one that I'm following now. Are we together? I'm starting from, or you are what? If you are on the study group, if you were added on that group, it means you have that document. I send the document, the mathematics, not in the course outline, but a certain document which has got 160 pages. Then I'm following that one. Are we having difficulties in opening our phones? If some of you are not fine, you are not able to see the document, can someone resend that one on the group again? Yeah, can you do that? We should not take much of our time because I'm starting. What people everything. Are you there? All right, I'm studying. You can restart your phone. If it's not working, you other phones are not responding. But if you are not responding, you switch it off and then you start again. Yeah, it's not Alright, let's start with ratios. If you look at what they have written there, they are saying that when we talk about ratios, they will show relationship on how one quantity is of the other. It means when we are looking at the ratios, we have got you are trying to compare quantities. One quantity and the other. That's the ratio. For example, you can have you want to compare X and Y. These are two quantities, but both have got the same unit. So we need to compare these two quantities. So we write X stroke Y, which is the same as X ratio Y. So when we talk about X stroke Y, it's the same as X ratio Y. So X over Y is the same as X Y, like this. Right? Of course, we are talking about you are comparing quantities. You are comparing X and Y. The first time you are comparing two quantities, the ratio will do it like that. Sometimes, if it's numbers, you can something like 1 over 2, of which the ratio can be 1 to what? 1 to 2. That's what it means there. That you are trying to compare two quantities. Quantity A and quantity B. So if you look at this one, you have got quantity A and quantity B. That's why you have got that. That we call that ratio. But ratios can be defined as the contrast of two or more quantities of the same unit. For example, they are saying in ratios, some of the fraction part is always equal to 1. Therefore, ratios is basically comparison. When you are looking about ratios, you are trying to compare two issues here. Where you are comparing one quantity and the other, that is what is called ratios. So, as we have already done that is ratios. But sometimes, here we are looking at the two quantities, quantity 1 and quantity 2. But sometimes, you can compare three quantities. That's why we have what is called continued ratios. Well, that's what I was saying, that is what is called continued ratios. Continued ratios. And come up many. But it's very simple. Example 5, I'm saying, in ratio, you are trying to compare two things. One thing and another thing. Then I'm saying, assuming one quantity is X, the other one is Y, then X over Y is the same as X to Y. That is ratio. And I'm giving an example here that half is the same as 1 to what? 2. Then I'm saying, sometimes instead of comparing two things, we have what is called continued what? Ratio. Where you are now comparing three what? Three things, not these ones. Right? That's why when it comes to continued ratio. So in continued ratio, you are looking at now three quantities, where the first one is at A, B, C, something like that. How many items are there? Three. And that is what is known as continued ratio. And in that way, if and only if A to B and B to what? That's the issue of that. So, where you have got A to B and B to C is given, is where you have got this scenario here. So, this scenario here is the same as this what is there. Right? Why is that we are saying that this is the same as that? Right? It's the same as something like this. If you look at this one, A, B, right? The value of, if you say A to B, right? The value of B can be the same as the value of what? It's corresponding to the value of C. That's why we have got A, B, and B, what? C. Because this B will be common. B is common. That we call that as continued ratio. Continued ratio, we have got in three items that we have compared. We have got one item, second item, third item. Whereas you say A to B and B to what? So this is the same as A to B and B to what? The meaning is B is common. The fact that B is common here, that's why I have A to B and B to C. That's what I say just A, B and what? And C. You will see from the example that I will tell you. Right. Let me give you an example one. Go to your whatever you are looking, go to example one. It is by example one. Example one, calculate the continued ratio ABC, where AB equals to 5 to 6 and BC equals to 6 to 7. That's an example one. Example one. Example one is calculate the continued ratio. Calculate the continued ratio A, B, C when A, B equals to 5, 6 and B, C equals to 6, 7. Let's see what the solution is. Solution is the same as answer, right? Yes. You know that, right? Well, sometimes wherever you are coming from, you go waiting, eh? You say, waiting. Your teachers will say, waiting or solution. Okay. Now, if you look at that one, we can see that in that given problem, the common quantity is B. B is found in both. You can see, look at this one. B is found in both, right? So this one, if you look at that one, it's the same as saying A, B, what? C. Something like that. Right? That's what they wanted us to do. Now if you look at that one, you will notice that for the first one here, it is 5 over what? 6. 5 to 6. Something like that. Right? And for the second one, this one, it is 6 what? 7. Have you seen that? Yes. 6 is B, 7 is C. Have you seen that? Then let's find out what is happening there. If you look at what is happening there, A, B, C will be what? Will be 5, then 6, then 7. We are done. Is that a problem?
I hope it comes like the way of
yeah, because there it is 5 and 6 and 6 and 7. So 6 is common. That's why we have 6 here. We have 5 and 7. So just 5, 6 and what? 7. If you have to write this one, 5 to 6 and 6 to what? 7. 6 to 7 is this one. 5 to 6 is this one. That's what it is there. When you have like that one, what you have done there, what you have sorted out, that is what is called in continued what? ratio. That is configuration.
Stand up your phone.
Huh?
Stand up your phone.
No, I think as this time around, I can't confuse it before. I can't be confused before. It depends. A, B, C, D. It depends. Let's say if it is A, B, C, what will be there, right? If you are given like that one, I think let's go.
1, 2, 3, 4.
Right? Oh, 1, 2, 3, 4, right? 1, 2, 3, 4. If you look like this one, so A B is 1, 2, right? Then B, C,
2, 3.
A, B, C, then D. B, C is what? 2, what?
2, 3.
2, 3. Then the other one?
3, 4.
3, what? 3, 4. Yeah, it works. Yeah, it works. If you want this one, the way it is, this one is what? 1, 2, 3, 4. It's like that. I don't. You understand what we are doing? Huh? Is there nothing wrong? Huh? Not yet. Alright. Let's look at again. They are saying hence ABC is that one. Now let's go to a rate. And we want to see the difference between ratios and rate. Let's look at the rate. These are ratios. A ratio is that where you want to like divide 20 into 1, 2, 3. That's what we are doing. You remember that, right? You are able to say, the teacher will say, divide 20 in the ratio 1 to 2. And you are adding the ratios and divide 20 and then you will divide out like that. You remember that one? Okay. Now let's look at rate. We'll see the example what I'm saying. Let's look at a rate. The only difference between a ratio and a rate is that a rate is not free from units of measurement. While this one, it is a free of units of measurement. Let's look at rate. The difference between the ratio and the rate. If X and Y are uniform information and both have different units, then the ratio AB is known as a rate. If X and Y are two uniform information and both have different units, then the ratio A/B is also known as a rate. Representation of rates and ratios. Let's look at that, what they are saying. I think in other words, what they are saying is that a rate and ratios can be represented in 3 ways. You see from the difference from the way we are going to represent the ratios and rates. Ways of representing ratios and rates. Ratios and rates. There are 3 ways of representing ratios and rates. 1. The first one, you use what is called a fractional form. So you have 1 as fractional form. Fractional form. The second one, apart from fractional form, we have what is called decimal form and percentage form. Fraction form, decimal form, and percentage form. Percentage form. These are ways of representing ratios and rates. We have got these 4 of them, 3 of them. We have got fractional form, decimal form, and you have that the percentage form. Now let's start with the fractional form. A rate and a ratio seems to be the same. The only difference is the way you present them. They look alike. But now let's look at this like the fractional form. In a fractional form, ratio and rate can be written in the form of a fraction. A rate and a ratio can be written in the form of a fraction. That is P over Q is the same as P over Q. Whereas because if you look at this one, this is a rate. It's a rate. But this can be a rate of which it can be again a ratio which is P to Q. It can be like this. Right? But the fact that we are putting it like that one, we are saying this is a rate. Then what we are saying is that the fact that this is a rate, P over Q is a rate, whereas the P and the Q are real numbers. If you look at P and the Q are real numbers. Where P and the Q are real numbers. Now we are coming back to what I call the real numbers. You remember we started with what I call the real numbers? What are real numbers? From our previous discussion. They are natural what? They are natural numbers. Very good. They are natural numbers. And examples of natural numbers? Alright. Okay. And natural numbers? 1, 2, 3. But we are again including a what? A 0, 1, right? So that was a 0, 1, 2, 3, 4, 5, half 9, right? We're going to have natural numbers, right?
Yes.
What
about artificial numbers?
Huh?
Artificial numbers.
What about artificial numbers? Okay, alright. So you are saying, what about artificial numbers? No, these are just natural. That's we see mathematics, they go just natural. We don't have artificial numbers. Right? Now, what I'm saying is, example, this is a fraction, eh? You know that, eh? This is the same as it's a fraction. Where P and Q, they must be natural what? Numbers. Provided Q should not be equal to what? 0. So you put it, these are natural numbers, where P and Q are real numbers. But Q, where P and Q are real what? They are real numbers, right? Provided Q should not be equal to what? 0. Why Q should not be equal to 0? Why do you think that Q should not be equal to 0? If you take your calculator, I actually say any number like 20 to the over 0. If you use your calculator, it's going to give you math what? Math error. What does that mean? It means it does not what? Exist. That's why it's called math what? Error. In other words, it doesn't what? Doesn't exist. Right? It doesn't. In other words, it is impossible. Right? So the rule there, when Q equals to 0, the rule they say you should not divide by what? 0. But it is possible in math to have 0 over 20. It is possible. Because 0 over 20, the answer is what? 0. If you use your calculator, it's going to give you 0. But if you take 20 over 0, it's going to give you math what? Math error. Why is your calculator working? Right? It's going to give you something like that. What does that mean? So when you are saying that one, this is a fraction. P over Q is a fraction. Where P and Q are real numbers. Provided Q should not be equal to 0. Therefore, those are called fractional form. They are ratios or they are rates. The second one, it is the decimal, this one. The decimal. Within the decimal, decimal form ratios and rates can be written in form of, like an example is something like, if you look at it, 1,000 kwacha to 2,000 kwacha. You look at that one, 2,000 kwacha. You can convert that one to ratio, right? Right? Of which this one, this can be again be written as, if you look at that one, this can be written as 1,000 over to what? 2,000. Which is the same as half. Is that?
Yes.
The same as half. Because when you kill all the zeros here, you kill all these 3 zeros and this one, you are going to get half, which is like that. Right? So that half is the same as 0.5. So this can be the same as 0.5. If you look at this one, it's the same. It can be this is the fraction, but the same fraction has been converted into what? Decimal. That's why it's the decimal form in ratios. Because if you look at this one, this is the same as 1 to what? 1 to 2, and this is a ratio, right? But as it is, this is a rate. The fact this is a rate, you can convert this rate to that. But you take it to a ratio, it's going to be like this. This is a ratio. But this ratio, I don't think that is the same as 0.5. What we are converting there, we are converting this rate here to 0.1, 0.5, and that is the decimal form. So the decimal form, it is this form here. While the fractional form, it was the one that we are looking at. Here, this is the fractional form, and this is the decimal form. Are we together? Huh?
Yes.
It's not yet.
Can we try another example?
Okay, right. It should be like this one. Let's do another example. Alright. Convert into decimal form. Right? Convert to decimal form. Right? The rate of ratio 20.
Every time we go in that type of number, you know, like 24.
Alright, you can put 24 to
Maybe 26.
26. Alright. 24, 26 like this. Right, let's do it like that. Very good. 24, 26. Let's go. If you know like this one, let's make it to be a fraction. How do you make it a fraction? How do you make this to be a fraction? 24 over 26. Right? 2 goes here. 12. 2 goes here. 13. So this is 12 over what? 13. And this is a fraction, right? Convert that one into decimal. Use your calculator. It's going to be 0.9. Yeah, no problem. 2, 3, 0, 7, 76. Alright, let's do it like that. Which is the same as, you can say, 0.932. 92. Alright, 0.92 to what? You don't give a no problem. You have to give a no problem. Alright? So here, what they're saying is, we have converted this to that. And that one is the decimal what? Yeah, that's the decimal form. Alright, let's go to another, to percentage now. Let's convert to percentage. Let's go to percentage. You know, this is the thing they become easy when you are working together. But when you are alone, it's 3 hours. 3 hours in an exam here, of course, that's this year. Your exams are 3 hours. You can solve those are the 300. Now let's look at percentage form. Number 3, that is percentage form. Percentage form. Right? Percentage form. In percentage form, the percentage form of the ratio and the rate is as follows. Let's assume the let's say 100 and the 200. Let's say 1,000 to. Alright, let's take another.
Yeah.
Which one do you think?
1,000.
Alright, 20 to 500. Let's take this one, right? 20 to 500, let's convert that. If you look at that one, convert it to fraction, it's going to be what? 20 over 500 fraction. And then, this is like that. So it will end up
1 over 2.
1 over 2.5. Alright? That is the fraction. Right? This is the fraction. Convert this fraction to percentage. That is what? So it is 1 over 25 multiplied by what? 100. And this 1 and there 4, right? So this gives you 4 what? Percent. That gives you 4. Right? You can see that you can convert the ratios. You can convert the ratios to rate. What you are doing here is they are rates. Rates are like fractions. Like the way you are doing it is like a fraction, it's a rate. Then that rate can be converted into either decimal, fraction, and percentage. Now, the issue is, one question you can ask, or one question that we have to remind each other is this one. We are here at the university. You are doing, you have your degree, which is in line to business. Why do we bother calculating these ratios? I will tell you the reason. One of the reasons why we are calculating this one is that some of you will be managers. And the fact that you are a manager, you should be able to analyze financial. You have to come up with financial analysis, especially when you are looking at it, interpreting data. In other words, when your interpretation of data will depend on this financial analysis. What we are doing here is we are analyzing. We're just analyzing. You can, if something is like suppose this ratio 1 to 2, suppose A and this is B here. You should be able to say, out of that, if I am to share, it means this one is going to get greater value than this one. Because based on this one has 1 and this one has got 1, is twice in this one. You should be able to say, if you should be able to compare 2 items in your business. You can have rice and you can have beans, right? You can see the price of rice and you can see the price of beans, right? These two, they are different quantities, right? And again, their prices can be what? Different. 1 kg of beans, 1 kg of rice, they have got different prices. So you should be able to say, which one can I go for? Can I go for this one? Can I go for this one? That's why these ratios are very what? Are important. You should be able to compare which one can you take? You have got the 2 entities. Entity number 1, entity number 2. Let me go for that one, let me leave this one. Let me do this one. You can even compare, even here where you are. You find the fees here, they are 300,000. You find Mark, they are doing 200,000. You can compare, where can you go? Can I go to where it's cheaper? Or can I go to this place? It depends because you are the manager yourself. Is that right? That's why the ratios are very, very important for coming up with the decisions. Therefore, here we are saying ratio analysis The ratio analysis used in suppliers of goods on credit, banks, financial institutions, investors, stakeholders, and management act as a tool to evaluate financial position and check the performance of the firm. For you to check the performance of the firm, you should be able to compare using variations. To say that my company is doing well or is not doing well, you need to compare based on the what? The ratios. Based on the ratios. Assuming that you have got two firms, two businesses, right? You have business A, you have business B. For you to know which business is doing well, you have to compare the ratios of the outcome, performance that is coming. And you can say, let me close this one because this one is not giving me anything. Let me go for this one. Or you can find another solution to beat the other one so that they have to go up instead of even closing them all. Because sometimes it's so good. The fact that you are seeing your business is going, it's not giving you anything and you close. Don't do that. In any business, you have to expect that there must be, they can be retained or can be what? Risk. In any business, there must be risks. A business without a risk is not a business. That's why our friends, they're able to buy project from this side, from Jesse. They are busy in town. They want to earn something. But there in town, they are being chased by the city people. You know that, right? That is a risk. But they cannot stop that because it's where they age. They get money from, right? Other people, they have nothing. What they know is to grow jamba in mango. But they are studying jamba and selling it in South Africa to get what? Money. But the risk there is very big. What? It's very big because they can be arrested, right? But they can't do otherwise because they have nothing. They have to do it. You have to face with that. In business, you must be a risk what? Taker. Right? Let's go to again, ratios are very, very important because some of you will maybe you will open your own hospitals. So the fact that you have opened your hospital, maybe you'll be responsible in taking breathing rate of individuals. So you should be able to say the way this one is breathing, comparing with another one, you say, at least this one, I don't think that is lasting long. You should be able to compare. Based on the results, this one might be this and this one should be this. This one has got 3 plus malaria, this one has got 4 plus malaria. So whom should I treat first? In that way, you are trying to compare quantities and that is ratios. That's why we are learning about ratios. You get that, right? So, the questions that I will be asking you in an examination is not only calculate, but I said it, based on your calculations, you have found that maybe, I can even give you a case study, and I say, can you justify why do you think that those ratios are very important in the real life situation, and try to give examples of your findings. So you should be able to say, based on this, we did this, and then this. That is university. It's not that you solve without understanding. You should be able to understand what we are doing here. You with that, right? Alright, let's go to another area. Another area is about, you can read it from that, as I've already said again, ratios are also used to calculate tax, audit requirements, utility to government, utility to employees, utility to shareholders, to investors, etc. Right? So you should be able to do like that. Let me just give you another example here. Another example number 2. Convert the given ratio 32 to 364. Right. Convert the given ratio 32. Convert the given ratio 30 to 360 into its simplest what? 4. Right? Convert 30 to 360 into its simplest form. So you can convert that one, right? So your solution will be like this. See? Mathematics from the university, they are very easy, smart. You look at this one, it is the same as saying 30, which is 30 to 360, is the same one, is equivalent to 30 over 360, which gives you 1 and here 12, which is the same as 1 over what? 1 over 12, right? And with 1 over 12, if you are converting it to that, which is the same as, it is the same as, which is the same as 1 to what? 1 to 12, like this one. 1 to 12. Another method of doing this is the same as saying 30 to 360, right? You divide by 10 here, it's going to be 3 to what? 36. Yes. You divide by what? 3 here, 1 to 12. And this is the same as this one we are finding here. Right? Are we lost? Huh? You are lost? Where? We know that it's 30 to 360 is the same as 10 over 360. We know that? Right? And then you divide. And then you divide. You come up with 1 over 12. You know that? Is that? Are we together? And that is the same as saying 1 to 12. Is that? Are you together? Yeah, that's exactly the same as the way we do it like that. Is that simple? Yeah, that's very simple. Right.